All right, guys. So today we're going to do some more practice with stoichiometry. This time we're going to do some longer conversion problems. So in the past week, we've done some mole to mole conversions. Yesterday, we also did a mole to gram. Today, we're going to do a couple of additional problems, some that involve more steps. So I'm going to give you some helpful hints and some tricks, work through a few problems with you. All right, so the first key to any stoich problem is to make sure that you have a balanced equation. This time it says that we have 4.5 grams of sodium chloride reacting with an excess of fluorine. First step asks us to write out that balanced equation. So I have sodium chloride, and remember that you have to make sure that your charges zero out every time you write a compound. So Na is +1, Cl is -1, that's happy. The sodium chloride reacts with an excess of fluorine. Remember that fluorine is one of our diatomics, so it will exist as F2. This is a single replacement reaction. So following the single replacement reaction, we know that the Na will pair with the F and the Cl will stand alone. So we need to make sure that our compound, again, zeroes out, and Na +1, F -1, it does. Chlorine is diatomic, so we need a 2 there. After everybody is stable and happy, at this point, we need to balance the equation to show the conservation of mass. You can do this making the list, as we've done in class. Otherwise, when you are done, you should have a 2 in front of the Na and a 2 in front of the NaF and a 2 in front of the NaCl. All right, so what that balanced equation gives us is our mole ratio. We know that this reaction will occur in a 2 to 1 to 2 to 1 ratio, but that ratio must be in the unit of moles. That 2 to 1 to 2 to 1 ratio does not work in any other unit, and it's important to remember that as we go through these problems. So the first problem asks us how many moles of sodium fluoride are produced. So the first thing I would do is identify which two substances we care about the amount of in the balanced equation. So I care about the amount of NaF and I care about the amount of sodium chloride. So I'm going to find those two in the balanced equation. I know that those two substances are related in a 2 to 2 ratio, but again, that ratio only works if we're in moles. So we're now ready to start problem B. It says how many moles of sodium fluoride are produced. When you start a dimensional analysis problem, you should always start with the number that's given in the problem. So we know that we are putting 4.5 grams of sodium chloride into this reaction. And I would like to compare the sodium chloride to the sodium fluoride and use that 2 to 2 ratio, but I'm not currently in moles. The current unit is grams, and I can't use the mole ratio until I'm in moles. So my first step is to convert this amount of grams into moles, just like we did earlier in the year. We're going to go to the periodic table, and we're going to find sodium, 22.99. And we are going to find chlorine, Cl, 35.45, and add them together. When we do that, we get 58.44 grams of NaCl is equal to 1 mole of NaCl. So we can use that in our next step to figure out how many moles of sodium chloride we have. Just like before, match your units top of one to bottom of the next. So I have 58.44 grams of NaCl, and that is equivalent to 1 mole of NaCl. By putting the grams on the bottom, I made sure that my units canceled out. Now, one thing to keep in mind, because we're dealing with several substances in the chemical equation, you want to make sure that you label not just the unit, but also the substance itself. That way you can make sure that it's canceling out. If I stop the problem right now, that would tell me how many moles of sodium chloride I have, but that's not what the problem is asking for. The problem is asking how many moles of sodium fluoride will we make. Well, we know that for every 2 moles of NaCl that goes in, we're going to produce 2 moles of NaF. So we can use that 2 to 2 mole ratio because we're currently in the unit of moles. So now we're ready to use that mole ratio. For every 2 moles of NaCl, I know that I'm going to produce 2 moles of NaF according to the balanced equation. So in the next step, I have to decide what goes on the top and what goes on the bottom. Because I have moles of NaCl on the top, I need moles of NaCl on the bottom. So 2 moles of NaCl will produce 2 moles of NaF. I'm now going to make sure that my unit and my substance cancel out. moles of NaCl, moles of NaCl. When the only unit remaining, moles of NaF, is the unit that the problem asked for, then we know that we're done. In order to solve this, I'm going to multiply across the top by taking 4.5 times 1 times 2, and that'll give me 9 on the top. And then I'm going to take 58.44 times 2, multiply across the bottom. That gives me 116.88. And now I'm going to divide my top by my bottom. And I end up with 0.077. I need to label the unit on that, and the unit is moles of NaF. The only unit that didn't cancel out in my problem. So don't lose track of what this is telling you. This is saying that if you start with 4.5 grams of sodium chloride and you put that into the reaction with more than enough NaF, we can expect to get exactly 0.077 moles of NaF out of this reaction. All right, we're going to try one more together today using the same balanced equation. And this time it's asking me how many grams of chlorine are produced. So I'm going to go back up to my balanced equation, and I'm going to identify the two substances that I care about the amount of. This time I care about the chlorine, and I know how much sodium chloride I have. So these react in a 2-to-1 ratio. So we know that for every 2 moles of NaCl, that's going to produce 1 mole of Cl2. I'd like to use that ratio, but I can only use the ratio when I have the unit of moles. So I'm going to start the problem with the number that's given. And again, I have 4.50 grams of NaCl. And I would like to compare the NaCl to the Cl2, but notice I can only do so when I am in moles. At the moment, I'm in grams. So the first thing I need to do is take my grams and change them into moles. Again, I'm going to go to the periodic table and I'm going to add up my Na and my Cl. And when I do that, I get 58.44 grams of NaCl is exactly equal to 1 mole of NaCl. I put the grams of NaCl on the bottom so that my units canceled out. Now if I stop the problem, I'd currently be in moles of NaCl. But I don't want moles of NaCl, I want grams of chlorine. The only way I can compare two substances is using that mole ratio, and because I'm in the unit of moles, I'm ready to use the mole ratio in my next step. So I know that 2 moles of NaCl will give me 1 mole of Cl2. I'm going to put the NaCl on the bottom so that my units cancel out, and every 2 moles of NaCl is equivalent to 1 mole of Cl2 in this equation. If I stop the problem right now, I would have moles of chlorine. But notice it does not want moles of chlorine, it wants grams of chlorine. So I'm not quite done. If I'm in moles and I want to get to grams, just like earlier in the year, I'm going to go to the periodic table and I am going to find out the mass by adding up the molar mass as written here. So I have 2 chlorines, which are each 35.45, so 35.45 times 2 gives me 70.9. So 70.9 grams of chlorine is equivalent to 1 mole of chlorine according to the periodic table. So in my next step, I am going to put the 1 mole of Cl2 on the bottom because my units will cancel out, and for every 1 mole of Cl2, I know that's exactly equal to 70.9 grams of Cl2. Notice that grams of Cl2 is the only unit that didn't cancel out, and that's what the problem asked for, so I know that I'm done. In order to solve this problem, I'm going to multiply across the top. So I'm going to take 4.5 times 70.9, and when I do that, I get 319.05, and then I'm going to multiply across the bottom. So 58.44 times 2, and that's going to give me 116.88. I'm then going to take my top divided by my bottom, and when I do that, I end up with 2.73. 2.73, and I need a unit. The only unit left is grams of chlorine. So what this is saying is that if I were to run a chemical reaction and start with 4.5 grams of NaCl, react it with enough fluorine, I would end up with 2.73 grams of Cl2. If we need to do a Zoom conference to go over any of this later, I will set up a time and you are welcome to join so that you can ask questions. I hope this helped.